Last time we said that we've been introducing the gates, but we also said that whenever we were thinking about the AND, NAND, or NOR, XOR, exclusive NOR, buffer, and NOT gate, we're only thinking about high level of abstraction circuit elements. Because even when we were thinking about something like very simple like the NOT gate, we actually went through and went through cutting down each and every level of abstraction till we managed to get to the real circuit and basically what a NOT gate does and how it does it and how it's implemented is basically this one with two transistors which basically have one with a NOT and one without. And then it basically depends on whether the input is 0 or 1. Then it's going to be either shorted to ground or not. If it is, then it's going to go. Then if it's 0, we want the output to be high. Therefore, I go straight from VDD to Q. If it's not, and if it's 1, so it's not 0 but it's 1, then we want the output to be low. So we said, okay, then this one is going to be closed, so it's shorted to ground, therefore the output is going to be low. So what do we do now? Well, this is pretty much it for the NOT gate because we managed to reach the implementation. Shall we do something a little bit more complicated? Yes, we want to do that. So today, what I'm going to talk about is the NAND implementation. So how does it look like? Well, it does look a bit messy at first, but that's only because you are actually still thinking about the analog circuits. But once you get into the digital world, everything is going to be like simple. Well, no, it's never going to be simple, but it's gonna it's gonna be easier, and I can guarantee you. Just joking, by the way. I'm messing. I'm just monkeying around. So this is our VDD, just like we have for the NOT gate. So our VDD here is going to be connected here, and it's also going to be connected here. So down here we have our first transistor with a NOT. And here is connected to the output Y. So this one is Y, and is our output. Down here we have another transistor all the way down to here when we have another transistor, and then here we have the ground, so VSS, which is our ground. I'm just not going to write VDDs. Our positive VSS is our ground, our 0 volt reference. We know that this is ground and this is VDD. I'm just gonna write VDD and VSS, and that's pretty much it. And I'm gonna write all the other thing because it's something that you should already know. So okay, so here we have our first input, B, with a transistor, and here we have the other input, which we're going to call A. But it's not over, of course, because from here we have another transistor going down like this. Yeah, I should really actually make those like this, because real transistors are actually like, yeah, just to make things a little bit more like how you see them in the real circuit. Okay, so, and then from here is connected to Y, so I should, yeah, I made it terribly. I'm terrible in drawing those things, by the way. So yeah, should be like this. And here we have this with a NOT. So this transistor with a NOT, which is connected to B, but not to A. It goes like this and goes all the way down to B. And of course, we also have A, the implementation for A, which is this one. So this is NOT. And here, of course, it goes all the way down here. It's not connected here, of course. It goes all the way down to A, like this. And we just do, this time we can call this Q1, this one Q2, this one Q3, and this one Q4. Just for our internal reference, and this one is Y. So what happens? Oh, I should really, by the way, I should name this. We're talking about NAND gate. So this is a NAND gate. Let's try to do something with it. So let's start with 0. So 0 and 0. So we're going to start with both the input as 0. We're just going to make our truth table just to confirm that it's actually acting like an AND gate. So our truth table, we have A, B, and Y, where Y is our output, just like we did at the very beginning of the course. So let's suppose that we start with the 0, 0, right? Okay. So 0, 0 is an AND gate. So if it was an AND gate, both of them had to have to be 1 in order for the AND gate to be 1. So if they're both 0, then the output is going to be 0. But this is an AND gate, so the output is going to be 1. So let's actually check that the output is 1. How do we do that? Well, let's see. We have 0, 0 here. So if we go to here, we got this, and we go to here, we got this. So this one is actually 0. And this one is actually 0 because it's just reading the value from here and reading the value from here. So if it's 0, then this one is going to be open and this one is going to stay open. Now, what happens here? Well, here we have a NOT, so here we have a 1, and here we have a NOT, so here we have a 1. So what happens? Well, this one is going to be closed, and of course this one is going to be closed because 0, 0. So the output goes straight to Y, so it's high. Therefore, this one is 1. So yeah, it's it works. It's an AND gate. So let's try with both of them being 1. So if they're both, no, well, let me try with 0, 0, 1. Okay, let me try with 0, 1 first. So let me try. This is no longer a 0. This is a 1. No, this is still a 0, so 0, 1, I want to start with 0, and this one is 1, okay? So 0, 1, so 0 is still going to be 0, 1, this one is 1, Here we have a NOT, so this one becomes a 0. Here we have a NOT, so this 0 becomes a 1. So what do we have? 1 here, so this one is closed. We have a 0 here, so this one is open. Okay, and we have a 1 here, so this one is closed. So what happens? Well, we have 0, 1. Okay, so 0, 1. If it was an AND gate, then both of them actually had to be 1 in order for the AND gate to be 1. So since only one of them is 0, the AND gate will be 0, but this is a NAND gate, so the output is going to be 1. So what happens? Well, basically happens that since this one is 0 and this one is open, even if this one is 1, so this one is 1 and is closed, it's not going to be shorted to ground, because once it goes here, this one is open, so it will be like a huge resistance, so the current is not going to flow to, it's not going to be shorted to ground, because only this one is shorted, but this one is not. This one is actually open, so even if B is 1, A is 0, so it's not going to be shorted to ground. However, since A is 0, this one is going to be a 1, so this one is closed, so the current goes here to Y. Therefore, the output is high. Let's go through it one more time with another combination. So if A is 1 and B is 0, again, we will have 1. So the output is going to be high because, you know, as I said, if it was an AND gate, then both of them had to be 1 for the output to be 1. So the output will be 0, but it is a NAND gate, so 0 naught is 1. So what do we get? Well, if A is 1 and B is 0, then here we would have 0. So this one will be open. Here we would have 1. So this one will be 1 and this one will be closed. Here we'll have 1 because this 0 naught becomes a 1. So this one is actually effectively closed. And this one from is 1, so with a naught becomes a 0, so this one is open. So what happens? Well, even though A is 1, so this one is closed, this one is open. So the current is not, you know, it's not shorted to ground, because once it goes here it's not gonna, it's gonna have a huge resistance because it's not gonna be shorted to ground. This one is open. So when it's open, it's a huge resistance, so it's not gonna flow here, the current. So it's just gonna stop. However, here, this one is closed, but since B was 0, this one is actually gonna be a 1. So here, although this one is open, this one is closed. So the current is going to go here, flow through here, all the way to Y. So again, we have an high voltage. Now, for our last case, where we have A as 1 and B as 1, well, if both A and B are 1, the output is 1, but this is a NAND gate, so 1 naught is 0 in the NAND gate. So we actually expect the output to be low. So let's see that. So we have A, which is 1, B, which is in this case is 1. So if B is 1, this one is 1. So this one is closed. Okay. It's actually closed. Yeah, let me just draw it like this. This one is closed. This one is 1, so A is 1. This one is 1, this one is closed. All the way here, B is 1, so here we have 1 naught, so it becomes a 0. So with a 0, this one is actually open. So it's not closed, it's open. A is 1, so this one is 1 and it's closed. This one go all the way down here, all the way up here, and is 0. So this one is actually closed. So this one is closed, it's not gonna flow. This one is closed, it's not gonna flow. And this one is actually shorted to ground. So the output is low. So 0. Yeah, bingo! It's actually working. It's working like a charm. It's fine. So yeah, this is how the implementation of an AND gate actually is. So yeah, whenever, as I said before, whenever you think about this, all right, so the NAND gate, so the AND with a NOT, so the NAND gate, which takes A and B as an input and Y, outputs Y as an output, just think that it's this one. It's actually this whole circuit here with 1, 2, 3, and 4 transistor with a certain VDD, which is our power, and a VSS, which is our ground. A and B, which are our inputs, and Y, which is our output. So again, this is how it works. Stay tuned. This is pretty much it for this video, but stay tuned because we are gonna go on with another video with yet another circuit.